through. Basically, installing some stuff takes a while with this notebook. So what I want to do is we'll start installing stuff, and then we'll take a break, and then hopefully by the time we come back, everything will be up and running. So you should have this notebook open. Is everyone able to get that open? Great. Okay, so really quickly, the first thing we want to do is let's run the top cell. I am purposely on the free. I create a free account for myself just to see what everyone else's experience is like. So I got a K80. What did everyone else get? Something like K80, T4, P100, something like that? Okay, cool. So obviously the K80 is the slowest, which is totally fine for this demo. We'll be able to do this. We're going to skip the next cell. For this demo, we don't really need to worry about Google Drive, but if you are starting to make longer pieces, you might want to connect to Google Drive. The next thing I want us to do is, well, the most important thing to do before we take a break is run this cell. So the title cell that says install OpenPose. Just go ahead and hit play on that. And then while we're waiting for that to load up, let's go to the next cell as well and hit play on that and just queue that one up. This one might take a little bit of time as well. So when we come back after our break, I'll explain what we just did. But these two cells take like 10 or 15 minutes to get set up. So I want to make sure we do that before we come back and are able to work on this. So let's take a 10-minute break. So we'll come back at 45 after, and then I'll kick off sort of a quick demo on OpenPose, and then we'll make a little bit of art today, and then we can see what we can make, and then we'll pick up again next week with more demos. So we might finish out. We might have a little bit more OpenPose stuff to do next week, depending on how long class runs. And then the following, like next week, we'll also pick up and do a little bit more of experimentation. So I'll see everyone in 11 minutes, and hopefully everything's been installed by then. Cool? All right, see everyone shortly.
And as I feared / expected, it looks like this is still only about 33% of the way done, so it's probably going to take a couple more minutes, but that's fine. What I should say is, so there was a note about should we copy this notebook? You probably don't need to copy it for this demo, but I would definitely recommend, as always, making copies for yourself. If you just go to File, Save a Copy in Drive, that'll make a copy for yourself, and maybe, unfortunately, like because of the tabbing, you might have to make notes for yourself in the other tab, but that way it'll save for you. So go ahead and do that if you feel comfortable. I try to document the notebooks that we'll go through in this class fairly well, I hope. But if you feel like there is something that I should add to this, let me know, because I'm happy to just add it and update it. So while this continues to install, let me talk a little bit about what we're going to do this evening. So we're going to look at this detection thing called pose detection through OpenPose. If you're new to machine learning and you haven't really dug around a lot, a common thing you will find is that most of these projects live on a site called GitHub. You might be familiar with GitHub. It is, for coders, programmers. It's mostly where software gets saved. But a lot of the good ones, or like the ones that we'll be looking at in this course, have a lot of documentation. And I do think, it's important that even if you don't know exactly what's going on, I do recommend that you sort of read through what's called the Readme, which is usually the description underneath here, just to sort of get a sense of maybe what's going on. Again, I tend to glaze my eyes over certain math symbols or other things, but I do try to at least read it just to maybe take in and understand a little bit of what's going on. This particular site also has an it's well documented, but it's kind of confusing website of all their documentation. So if you are a programmer and you want to dig in, we'll be doing a pretty high level overview of how it works, but if you are interested in digging in more, there's a lot more information on how to use it here. So for those of you who want to dive in and really get your hands dirty with this, there's a ton of good documentation as long as you can find it and read through it. So another thing, since this is the first sort of demo we're going to do in class, I just want to say a lot of these demos will get you maybe half to 75% of the way there to making your own piece. These are meant to be more like quick bite-sized, sort of like here's an idea, here's an idea, here's an idea. We won't necessarily go really deep into like how to like fully do everything. But if you are interested in a topic, I would love to either chat over Slack or in a co-working session to give you any guidance or help that you can get to like take this further. So like for example, in this one, we're going to be using both Colab and p5.js. And if you are unfamiliar with either of them, but you have an idea on how you want to make something, like please let me know and I'm happy to walk you through stuff. So like I know lots of times people are like, oh, I don't want to bother Derek, like whatever. Please bother me. Like the reason that you paid so much for this class is that you have access to me for the next 10 to 12 weeks. Don't be afraid to use it, right? Like you paid a good amount of money for this class, so please utilize me if I can help in any way. So yeah, like this will get you a cool little like tech demo, but if you have an idea on how to make it an idea fully fleshed out of yours and you're feeling stuck somewhere, like please reach out to me and I'm happy to like either talk about it in a co-working session or schedule more time to like sort of help. Because this also isn't a P5 class, but we'll look at a little bit of it. But if you're new to P5 and want some help, I'm happy to walk you through things. 72%. Okay, let's see if we can get there. So I can just quickly show you what the end result of this is going to be. So what we're going to do is, as I mentioned, we're going to take a little short piece of film. So actually, what I should say is, if you have your video downloaded and you, the next thing to do would probably be to upload it. So the easiest way to upload to Colab is just to open up your folder, your Finder like file folder over here, and then just drag your video into it. So I'm just going to go over here, find my video. Yeah, it's this one. And then just drag it into Colab over here, and that'll be uploaded. I'll give you a little reminder that that it's only uploaded for as long as you're running the system. The other way to do it is, if drag and drop doesn't really work for you, there's the upload to session storage button here, which you can click, and that'll then open a Finder window to upload your file. But I recommend uploading it now in case it's a little large, and you can upload and install stuff at the same time, so we might just want to do that just to make sure that we're all set up here. I will quickly show you just the video that I'm going to use. So I just have this little video of someone dancing. And it's about 20 seconds. So obviously the longer your video is, the longer it's going to take to process. I recommend just playing around and starting with short stuff just so that it doesn't take forever. And the other thing to know is the larger your video, like dimension-wise, also the longer it takes. And in fact, on a K80, you may have issues with too large of a resolution of video. Usually, with most machine learning things, the higher resolution things are, the more processing power it takes. So if you're on a K80, you might be stuck, just with that. Okay, so I'm finished installing here. So let me just talk a little about what we did. So the first thing we did is we just installed all of the OpenPose software. So this just runs a bunch of code. I honestly couldn't tell you what half of it does, but I know it works. And unfortunately, that is kind of how I approach a lot of these tools. I just cut and paste until it works. I know we just installed a lot of stuff, and I'll say that this also, because of dependencies or whatever, is a really pain in the ass to install locally, even if you have your own Linux box. So I definitely prefer using OpenPose in Colab. So that installs this. The other thing that we did is we installed the latest, or the what's called Body 25B model. Body 25 is the actual model that OpenPose is trained on. By default, it doesn't come with the B version, and I have found that the B version is far more accurate than the other version. So I definitely recommend installing 25B. As you may guess, you'll see that this is meant to be real-time. I haven't found it to be that good at real-time, but it says it can. 25B is more accurate, but slower. So because we're working with video, I think it's okay if we are a little bit slower but more accurate. I think that'll give us a better video long-term. So that's why I recommend installing this version to use. So now that we've installed our software, we can go ahead and take a look at how to actually use this. So also, I think, Victor, I think you said you have a YouTube video. So there is, if you run this cell, this will install this thing called YouTube DL, which will allow you to download video directly from YouTube. It's pretty cool. Then you can run the next cell. So this cell, this URL is the video that you want to download. So if you do want to download a video from YouTube, just replace this URL and then run this cell. I'm not going to do it because it's kind of slow, but if you do want to download a video, you can. Also, video on YouTube tends to be either fairly low res or very high res, and then it's like you've got to download a video, and then it's like length or whatever is also an issue. So just beware of that. But these are the two cells to run YouTube DL. There are not any video format restrictions for this particular demo, in part because what we're actually going to do is just turn it into a bunch of frames, and then we'll run it on the frames. So that's essentially what will happen with this demo. So I think most formats will work. Pretty much anything that FFmpeg can read will work just fine with this particular model. One other thing is I recommend that we, for this demo particularly, scale our video down to 480. This line, what you can do is you can, in the left-hand panel here, if you just right-click or control-click on your file, on your video file, you can just hit copy path, and then replace this first path with your video, and then you can leave this as is. So actually this should be scaled. This will scale your video down to whatever dimension it needs to be by 480. So this will scale your video and keep the scale factor. So this will make your video smaller by 480. If you run the cell, like I'm gonna run the cell and I know I'll get an error message. So I got an error message that said, error initializing stream. This says width not divisible by 2. So what happens here is that because I'm trying to scale, I believe it's a 1280 by 720, because I'm trying to scale this down to 480, it gives me an odd width. And in video, you can't have an odd dimensional width. So you have to have an even width. So if you get an error that says this, what I recommend doing is just taking this dimension and uncommenting the next line. So comment this line out with just add a hashtag in front of it, and then remove the hashtag on the line below. And again, copy your path in here, and then change the scale values here to just paste in whatever that width dimension is and just make it 1 pixel smaller. So this will slightly stretch your video or slightly shrink your video, but it's by a pixel, so no one will really notice. So you can go ahead and run this, and that will correctly resize your video. Any questions about that so far? So right now, all we're trying to do is get our video in the right format and to make it a little bit smaller. So what I would say is for this demo, because I want to go through things fairly quickly, it's good to scale your video down. As you begin to work with your own pieces, it's fine to leave the video scaled as is, and I'll show where to make a couple of edits or changes to the code we're going to run, just so that it'll still work for you regardless of dimension. Any questions so far? All right.
Sorry.
Go for it. Yeah.
So I did the copy path, and then so you replace the content painted trim.
Yep.
With the path. Okay.
Yep. Yeah. Replace this with your path to your file. All right, so the next thing that we need to do is we actually need to learn a little bit about our video, right? If we download a video from YouTube, we maybe just learned what the resolution is, and we have to work with that. We probably don't know the frames per second. You can upload pretty much any frame rate to YouTube, and it just sort of deals with it. So we want to learn a little bit about that, and I believe we also want to learn, let's see, what else do we learn? I think we have the resolution, so that's fine. So this line of code here will give us some info about our video. So if you ran this first line, your video might be named scaled, And if you ran the second line, your video might be named Scaled Forced. Just take whatever the correct name is. And again, you can come over here and if you refresh, you'll see what your video file is named. So by default, this is the thing that I do pretty much all the time is just copy the path. Also, because my keyboard is jacked up, it's easier for me to copy a path than to try to type it and miss keys and stuff. So I'll often just paste that path. So ffprobe is kind of like ffmpeg, except all it does is tell us information about a video. So we'll go ahead and run this cell. And it spits out just a bunch of stuff that I certainly don't know about. Maybe you do, but probably I would assume many of us do not. There's a couple things we're going to look for. So down here, there's a duration. Just want to make sure that your duration matches sort of the approximate length of your video. Wasn't cropped or anything or cut. And then you want to look at stream. Most of us probably have a stream 0 and a stream 01. Stream 00 is often your video, and stream 01 is often your audio. It's probably rare that any of us have more than one video stream, and it's possible but unlikely that we have more than one audio stream. Digital video, you can jam a bunch of streams and stuff, and it's pretty messy, but mostly what we want to look at is what the video stream is. So just make sure you find video, and then what you're going to look for is, one, you're going to look for the dimensions to make sure it matches whatever dimension you were looking for. So mine's 852 by 480, yours is probably something else by 480. And then the other thing we want is frames per second. So mine is a weird value of 23.98. Yours is probably like 24, 29.97, 30. You know, this could really be any number, but we just want to make sure that we keep that number in mind because we're going to pull the video apart and then put it back together. And if we change the frame rate, the speed might change. Maybe we like that, maybe we don't, but just keep this in mind as we do it. Everybody got that? Okay, cool. So next is, there's a couple different ways to run this. You can run this pose detection directly on the video, or you can run it on a folder of images. I prefer running it on a folder of images, probably just because there's some form of like control here. Like I know I'm getting one frame every time. For this demo, it doesn't really matter either way. But let me just talk a little bit about what we need to set for these. So in each of these cells, pretty much anything above this line is stuff that you'll need to set more or less for every one of your videos. So this is going to do the pose detection directly on a video. And so what we want to do is we want to take our path. So we'll copy the path, paste the path inside of the double quotes. And then we need to set the video height, which for most of us should be 480. So I left this as 480, just make sure it's set there. And there's two output paths we want to set. So the first output path is, this is where we're going to save our files. This is where it's going to save all of our coordinates. So what this model does is it'll go through our video and it'll pull out the person and it give us a bunch of coordinates for where their quote unquote skeleton is. And then we'll be able to use those coordinates. So this is where we're going to save those coordinate files. And then what it also will do for us, it'll also produce a video of sort of like an example of what that video looks like with that skeleton overlaid on it. And it's important to actually produce this video because you want to sort of see what happens because some videos will actually have issues. And I'll talk a little bit about that in a minute. But these are the three things you want to set. For this, you're probably fine to just leave these as is. But as you produce more and more videos, you want to get in the habit of naming things in a way that is not confusing. So if you run this a bunch of times and you have scaled force skeleton, scaled force skeleton 1, scaled force skeleton 2, you will be like, what the hell are these files, right? So getting in the habit of naming these in a way that like makes sense to you is kind of important. So just use that. The next thing, which again for this demo doesn't really matter. So I'm going to skip running this cell just to talk about the next step. The other step is you can run this on a folder of images. In this case, what we could do here is we can actually take our video and split it into a bunch of frames and then run the pose detection on each frame individually. The difference between these two, there isn't really one, other than the fact that like this one, I can remember what the frames per second value is. And then I can what I was doing in some videos was actually bringing those frames back into like After Effects, and I wanted to remember what the frame rate of these things was. So where I wanted to like sort of combine frame rates of different things. So this gives you a slightly more control. So I'd say depending on what you're trying to do with it in the output, one of the others of these will be important for you. But let me just quickly talk about what this does. So this command, what it does, it'll make a temporary folder here. And then the next command will split our video into a bunch of frames that are all numbered. So I'm just go ahead and run this, and then we can look at it because it's probably easier to understand it once we run it. So this will make a folder over here called temp frames. And again, for this demo, it's probably fine to name this temp frames, but you might want to name this whatever your video is. So this were like painted trim, I would change it to painted trim. But for this, I'm going to leave it as temp frames. And what you'll see is this finished. So it should only take like a couple seconds to run this on a shorter video. When you open up temp frames, just by clicking on this little arrow, it can sometimes take a minute depending on how many frames are in your folder. So you'll see we have a bunch of frames, and they're all numbered with like 9 digits. 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way up to the finish of our video. So this it takes the frame rate, and it literally looks at the frame rate and then takes each of those frames. So there's no like duplicate frames or anything using this technique, which I kind of like. Not to say that this would duplicate frames, but this is like very clear and precise, right? This you might not know. Is it going to duplicate frames? Is it not? So this way I just know for sure that I'm looking at only an individual frame each time. Okay, and then the last thing we can do here is we can actually run this script, and this will again create all of our pose structures for every individual frame. So this one has mostly the same things. There's a couple of changes here. So instead of pointing to the video, which is what we did in that previous cell, this one points to the frame folders. So if you named your frames differently or put it in a different folder, make sure you copy the path and paste the path here. We set the video height again. We again set an output path for JSON. So these are in a JSON format. If you're familiar with JSON, you probably know what that is, why it's helpful. What's nice about JSON is it's readable by pretty much most computer software. So we're going to be taking these over to p5.js, which also has a way to read JSON in. Whereas if I were to save these as like a NumPy format or some other format, it couldn't as easily be read in by other pieces of software. So this will be writing to JSON. And then because this is now been split up, we want to make sure the video we produce is back in the right frame rate. So we're going to set the video frame rate here. And then we want to give an output path for where to save our video. So now we can go ahead and run this cell. This will, on a K80, probably take a couple minutes. On a P100, depending on how long your video is, might be done in a handful of seconds. I think I ran this earlier today, and it took about 5 to 10 minutes to run. So while this runs, I'm going to talk a little bit about what it produces for us. I went ahead and produced this video already, so we'll take a look at what it does for us. As this runs, what it does is it uses the machine learning model to detect where the body pose is in this video. And the reason I said to hopefully only have one person in the video is that it will track every person in a video sequence, which is great. But if you have multiple people and they're crossing paths, it will lose track of which person is which. So by only having one person in here, you'll see there's a command here at the bottom that says number of people max 1. It's only going to look for one person. And if you have more than one person in that video that you use, they might switch. It might only find one person it might find person A half the time and find person B the other half the time. And that can get very messy. If you do eventually want to do a video with multiple people in it, I'm happy to talk with you in like a co-working session about what to do with that. But it can be kind of tricky because OpenPose doesn't track those people, so you'll have to like manually go in and be like, okay, which is person A and which is person B, and does it always stay consistent? Again, it's gonna be kind of a headache. So for this, I would definitely recommend when you start with one video or one person. So, excuse me, when this finishes running, we're going to get a video, and if you didn't change the name of your video, it's going to be called folder skeleton .mp4. I went ahead and downloaded my version already because I just want to show you what it looks like. So what you'll see is you get this rainbow colored frame, and it has sort of the skeleton overlaid on top of it. So what this is saying is at this frame of the video, here is what it assumes or detects the body to be. So it looks at, it'll be, I don't know, wrist, elbow, shoulder, hips, knees, ankles, and feet. And it does some face stuff. It does like the top of the skull, left ear, right ear, and nose. I'll show you where that's documented if you ever want to pull apart those sequences. If you have a person that is not full body, it'll still show sort of what it thinks it can see. So if you're cropped from like the waist up, it'll still try to show you and detect where the hips are, where the shoulders are, those sort of things. So it can do cropped bodies as well as full body. One thing I want to note is, and the reason that it's really important to make these videos is that sometimes right there, it can't detect anything, right? These are machine learning models, they're not perfect. So there are moments where your video will not see a skeleton. And if we look at this frame, we can kind of guess why, right? This person's a little blurry. This person's also wearing a hood, so their whole face is also covered. And essentially this model just can't figure out where the skeleton is. So as we work through this, well, we're gonna need to figure out what to do with this frame. Maybe if we have time and our client or whatever we're trying to do, like we need to know exactly where every position is, we may have to go in and manually edit those positions. These are given to us in a pixel coordinate, so it's X from the left and then Y from the top. So you could go in and manually say like, okay, it's, this is maybe like 300 pixels to the left, 350 pixels down, that's the left hip, right? So like, you could manually do it. You could maybe try to find if another machine learning model is better for your particular piece of video. But this is a very common problem that we'll run into with OpenPose. And depending on your video, so this is a thing I used for my video looking for you. Most of my dance videos were super low res, taken from digital video and uploaded to YouTube at like 240 pixels tall. And OpenPose had a really hard time finding a lot of those videos. They're grainy, they're blurry. So I had to sort of work my way around that. For these videos, assuming you find something good quality or like you shoot your own thing, you should get pretty good results. For example, like this video looked like it worked pretty well, right? Like I can see a couple little flickers here and there, but for the most part, it works well. So just beware that like, this is machine learning. It's never going to be perfect. Even, as she crosses her body, there's probably stuff that gets messed up a little bit. So just beware, never perfect, but we will get pretty interesting results. So this is the video, and it just sort of gives me like a approximation of what all these, what it sees as the skeletal frame. Let's see if this finished. It did not finish. Does anyone have a shorter video or a faster machine and has theirs finished?
Mine is finished.
Okay, cool. So I'm just going to talk a little bit about what should happen. And actually, we can look at this. I think it'll save them sequentially. So inside of folder JSON, which is where we saved all of our JSON values, our JSON files, if we open this, actually, anyone can open this. We don't need to wait for our videos to finish to do this section. Inside of here is a numbered frame and then a key points and then a JSON file. And if you double click on this file, it should open all the way on the left-hand or on the right-hand side here. And you'll see it is a single line of code. And it will say, here's the version. This is just the version of OpenPose we're running. And then there will be an array of people. So we can move this onto our own line just for this demo. So this will give us the array of people. It tries to guess the person ID. Apparently this doesn't work. They haven't built this yet in OpenPose. So it'll give us a person, and then it will give us their pose key points 2D. And I'm just gonna I'm gonna download this. Oh, right click format document. Let's see if that works. There we go. Perfect. There you go. Awesome. Thank you. Thank you, Ben. That was really helpful. I didn't know that existed. Before, when you actually even like a year ago, if you double clicked on a JSON file, it just downloaded it. So they're adding new features into Colab all the time. So if you go and right click and then hit format document, that'll format this in a prettified, easy to read way. So one of the challenges, or one of the fun things we're going to find out about the way these key points are given to us is if you count how many key points are here, there are 75 total key points. And what this is this is the X value of the first key point. This is the Y value of the first key point, and this is the confidence that the machine learning model assumed that this is where the point should live. And this is a percentage. So this is 72% confident that this was the right key point. We don't really need to worry about confidence. I don't know, maybe there's some artistic way to use confidence values. But what we're going to actually end up needing to do is combining these back together to get an XY value. And there are 25 of these because, let's see this finished, but I'll go ahead and show you. At the very bottom of this page this is the key for the key points. So point 0 is, I guess, the nose. I think that's what refers to the nose. So those first three values in that key points array is the X value and the Y value of the nose, and the confidence that that is the position for the nose. So 1 is apparently somehow like the center of the chest. So the 4th, 5th, and 6th value of the key points correlates to this. Then this is, what would that be? 7, 8, 9. So like, there's kind of a challenging thing where like we don't really get this in a very easy to read, digestible way. So when we move this to P5, we're going to have to kind of like recombine these things to actually use them in a meaningful way. So yeah, like just know that like we still have to do some work to actually put this back together. So the last thing we're going to do before we move to P5 is we are going to combine all these files together. One thing is like we don't really, P5 as a way to load JSON files, but we probably don't want to load every single one of these individually. So what we're going to do is this line of code will just literally combine all these into one file that we can then download and move over to P5. So the only thing to be sure of is just make sure that your folder directory is the correct path. If you just follow along with me and didn't change anything, you're probably fine for this. But you may have edited it in the future, or in the future you may edit it. So just make sure that this is the correct path. And lastly, I should also say, like, we're all going to combine this into a file called combine.json. But again, for future purposes, it may be easier to name this something that is actually clear about what you're looking at. So I'm just going to run this. We can use combine. That works totally fine. But for future, you probably want some clearer direction for what you're making and what you're doing. So we'll go ahead and run the cell. So just hit the play button here. And that should take literally less than a second. So what you'll get is a file count. This will tell you how many files, how many frames we combined. So that's it. And then there's a file over here called combine.json. So go ahead and right click on this and hit download. And that should download a file. This is the second file, so you can see I'm very messy with my naming conventions, but I already downloaded this file, so it downloaded to my desktop. So we are actually now done with OpenPose, so we can go ahead and shut off our machine. I always recommend that you shut off your machine when you're done with it, because if you let it run out through its runtime, you might get dinged by whatever crazy algorithm Google has to give you GPUs. And if you abuse this and leave this open for too long, too often, it might actually even stop giving you a GPU. So to like stop running is to come over here and click on the little arrow and go to Manage Sessions. And you should only have one file open. It should be this file. And just click Terminate. And that's just going to stop your file. And then down here at the bottom, well, toward the bottom is a direction to just download that file, and then you can click on this link to open the p5.js. I'll drop it in the chat in a second as well, but this should open a file for you in P5.
Can you repeat that last step?
Yeah, so we already downloaded the JSON file. Is that correct? Okay, so then you either need to click on the link that I put in the chat or this link just to open up the p5.js web editor. And if you're used to using P5, you might know that the web editor is a little wonky. It's totally fine for this demo, but if you get comfortable using P5, the web editor is not my favorite use of this thing. But yeah, so just bear with me as we figure this thing out. And I think if you open this URL, can you save your own version? Do you have to download your own version? You can save your own version. But Naoko, you also have a P5 account, is that right?
Yes, I was already logged into mine.
Okay, so if you don't have a P5 account, you might need to make an account in order to get this file to save into your own location. What I'll do is I'll download it and zip it up, so if anyone wants just the files, like I can give you access to that as well. If you know how to use a web editor and you like using Sublime or something else, you can totally use that. For those of you that are not new to P5 or just like have never used it before, it's probably fine to use the editor today, and maybe in a co-working session we can just make sure that you get yours running. Since I only have about, you can use your, okay, so there's other ways to get access to this thing. Since we only have 10 minutes left, I just want to quickly go through what we can do with this once it's in P5. And then if people want to like play with it more, maybe a co-working session or hitting me up over Slack will be a good way to just sort of go through it. Okay, so the first thing we need to do is we need to upload our JSON file. The way to do that is to click on this little arrow button up here, and that opens sketch files. And you might see my combine.json file there. So the first thing let's do is let's right click on this, if it'll let me. Let's see, right click. Oh, it looks like I have to save a copy of this file. This is annoying. Okay, so I'm gonna log in. All right, so since we've got 2 minutes, everyone make an account real quick, and then we can actually play with this. This is why I don't like this editor. You can't just edit stuff. You have to actually like create an account and save your own files. All right, so I have an account, so I'm just gonna open up 1Password here and log into my account. So I believe at this point, you need to log in, create an account, and then you can hit duplicate, which will duplicate a copy for you, or Command S might also save it for yourself. For those of you that logged in, what did you do? Did you just hit duplicate or did you hit save?
Duplicate.
Duplicate, okay, so hit duplicate. So once you duplicate it, then you can edit your own file. Wish this were a little bit easier, but it's better than having to download P5 and install everything yourself. So we'll deal with it. So once you have your own file opened, you should then be able to see there's a little arrow next to combine.json. Go ahead and click that and hit, oh, interesting. Okay, so you might also, if there's a cookie pop-up, you have to enable cookies as well. Whew, boy, okay. So once you click on this, then you hit delete. So just delete my JSON file. And then what you need to do is upload your own. So you'll come to this very top arrow right next to sketch files. Click on that arrow and hit upload file. And then you can either drag and drop, or you can click in this little file browser window. And you can upload, let's see where mine are. Mine are in downloads. And JSON. And when it finishes uploading, when this bar is black and you see it over here, that means it's uploaded. You can go ahead and hit X. So this whole file is already set up for you to use. I'll just quickly show you what it does, and then we'll go through like 1 or 2 examples. But essentially what it does is it reads through all the JSON values, and then it converts them to frames. So basically we'll like take every file value that we had as a JSON file as an individual frame, and it will read in all those points. And if you're interested in the code or you want to talk through the code, I'm happy to talk through it a little bit more. But this function that says draw pose, this is the function that allows us to draw each of these pieces. And if you know how a for loop works, this is the for loop that loops through all of our key points. Remember, there are three points for every individual point. there's the X, there's the Y, and there's the confidence. So we're looping through each of these as, basically we're skipping every 3. And then we're just using the X and the Y. And we have to do a little bit of what I've done here is, remember how I said that sometimes there are empty frames in here? This checks to see if we have an empty frame. So all of the debugs should be worked out for you here. And if you just go ahead and hit play, this should just run. And what it will get is we will get a cool little animating sprite of all those points. And let me do one thing here, because I realized I left this in. The way this works is that if you've never used P5, P5 draws every frame in this draw loop. So the way this works is there's a preload function that loads in files before the whole thing runs. There's a setup function. The setup function only runs once. It runs when you start up the program. And then the draw loop runs every frame. So one thing I should note here is if your frames per second in your video is not 24 frames per second, you might want to edit this number. So yours might be 30 and you just hit this to 30. What this does is this forces P5 to run at the same frame rate as your video. So mine was 24, so I'm gonna leave it as 24. A cool little trick of how P5 works is if you draw a transparent background to every frame, you get this cool like trailing effect. To turn that off, you just set this value to 1. That just means that what it's going to do is it's going to draw a black frame every time it loops, and then what you will get is this. So these are just the pose points of every video, or of every frame. And you'll see like there's a couple frames where it really skips because there's nothing that it can read in. One of the challenges of doing this both with the machine learning but also in real time, if you try to use OpenPose real time, is far worse. It will often skip lots of frames. You have to figure out how to like work with that. So one of the challenges here is just working with that as a limit or a constraint. So this gives us every single pose or every single key point. It does not give us what that video gave us, which is that structure, right? And that's because if we really want to do that structure, we're going to have to draw every single line. We're going to have to take point 0 and draw a line to point 1, take 1 and draw it to 2, take 2 and draw it to 3, take 3 and draw it to 4, skip 4, draw 1 to 5. So I didn't do that work. Maybe I'll do that work before next week's class if anyone wants that. But there's a lot of cool things we can do with this now that we have this, right? So one thing we might want to do is what if instead of dots, so we can go back to let's do our trailing guy again. So the way to do trailing is to change this background to a really transparent value. So this value takes in a 0 to a 1. So level of transparency is 0 is completely transparent, 1 is completely solid. So if you want to edit this particular value on line 28, you can do that. And then instead of doing circles, let's do a rectangle. And instead of a rectangle, we'll also do a hue change. So what I will do here is this. So in processing, if you change a fill color, you also need to change the fill value every time you want to draw that shape. So what this is going to do is I have a hue value that I've set as a variable. Up here, it's going to start at 0. So we're going to use Hue Saturation and Brightness. That's a cool little trick that gives you, it starts with hue. You might be used to RGB values where to compute a color value, you need to have 3 RGB values. P5 allows you to set what is called Hue Saturation Brightness, which is set, where do I set it? Here. So there's a color mode, Hue Saturation Brightness. So what this will allow us to do is we can keep the saturation and brightness values the same. And then what we'll do is we'll cycle through hues, which is just like a cool, like everyone does it with P5 or processing or whatever. So every time we draw a frame, we'll change out the hue color. This is a fun little pattern that keeps it within the range of 255. So hue always has to be between 0 and 255. So what we'll do is every time we'll add 4 to it. So that means like, I don't know, what does that math equal up to? Something like every 50 frames or something, it'll cycle through colors. And then we will use a rectangle and a rect mode of center. sorry, I'm flying through P5 stuff. If you want more P5 demo, let's talk during a co-working session, or maybe I can upload some videos in our Slack channel for folks. But I'm just going to quickly show you what you can do with this. And then what I'd say is, like, if you have a cool idea for this, like, let's talk about it, and maybe we can, like, I can help you build it. So what this is going to do is going to draw a long rectangle, right? Sort of like Anima. You know how Anima was like those long stripy patterns in a lot of it? So that's what this is going to do. And so you get those nice trails and a little bit of the rainbow color. And I also have another couple lines here. If you uncomment these lines below here, there's also a, this will give us like an extra trail. This will give us a second trail of color that is like slightly offset from the other one. So this is my very janky, made in 30 minutes version of Anima. Not nearly as good. You know, maybe if you want to really recreate Anima, we can talk about how you would go about doing that. But this is, again, like a really fun way to use those key points and then be able to draw people, right? And I think what we talked about with Anima is that, you know, it has that organic motion without having to like fake it, right? It's really rendering from video how someone moves. And even though they're kind of blocky, it doesn't feel perfect. I think it's like, it's getting closer and closer to that like fluid motion. So I should mention OpenPose can also do hand tracking. So if you want to track just hand motion, you can do that. It can also do face tracking. You have to set those separately from the whole body pose. So if you want to do something that's like purely hand tracking or purely face pose, we can do some work with that too. And I can add some comments or some stuff to that code to get access to it. But I think this would be fun. You could also think about maybe recording you can get a second video, right? And then you can run through the same process, and all you want to do is change your file name and upload a second file. And then you could even load in, the way to do that would be to do data too, and you can read in the same sort of values, and then you have people dancing across each other in different ways. So I think there's some really interesting things we could do with this. Again, this is like sort of the like, let's get just close enough to make it something cool, but not cool. And then maybe like if anyone's really interested in diving into this more, we can take time throughout the next couple weeks to like really explore this and do more with it. Does anyone have any questions?
What's the D and P4 in the code?
Where do you see that?
Below, in rectangle at the end.
Oh, so this is a trick of processing, is that you pretty much want an integer value. The code gives us the pixel values aren't actually like a pixel value. It's like 40.3765. So what this does is it rounds it. And then what D and P does, so again, because I'm a coder and I love short variable names, D is just literally the key points for that particular frame. And then P is the position value. So this is essentially what this is. It loops through all of those key point values to give us each one individually. So P starts at 0, so it's the first and second values. Then we skip the third to get the fourth and fifth values, and we skip that to get the seventh and eighth values, or whatever the math is there. I'm happy if people want this documented better. I can also do a little bit more documentation around like what each of these values stands for. The challenge here is that if we want to draw the skeleton rather than just get the individual points, we'll probably have to do some manual stuff of like saving them, because you can't just draw X to 1, like you can't just put 1 to 2 and 2 to 3, because at some point it jumps, right? So we'll have to probably save these and then know how to draw the skeleton. So what I'll probably do between now and next week is I'll also write a new function that draws the skeleton. So if anyone wants to play with drawing skeletons, they can do that as well. And then Natalie, I know Natalie, and I think Skullface, you were also saying like you guys like to play with shaders. You can also pass these values into like a fragment shader. So if you have, shaders are not my deal, But if you do have a lot of knowledge with shaders and you know how to pass coordinates in, you can also do something like that.
Okay, thank you.
Yeah, of course. Yeah, and also I should say, like, if people want to share their key points, just upload them to Slack. Like, just say, here's what the video is, and then share your key points, and then maybe we can make some sort of collaborative video of like everyone's skeleton dancing in different ways. It's perfect for the season. So I should mention quickly, if you need to leave, please take off, but I'll just mention really quickly, what I did for the Looking for You video is this process for about 2 million frames of video. And then what I did is I have another script, which I'll share next week, if anyone's interested in getting it. Yeah, of course, yeah, bye. I actually took all those values, and what I did is I compared every single frame of video to the key points, and I basically gave a single image as like a guide, and I said, find the closest other frame to this. So you do like a distance subtraction thing to get the closest value for where they match up. And then I like create a bunch of files from that and then dump them all into After Effects and overlay them. And then there's a bunch of crazy I wrote a bunch of After Effects scripting to like do various animation like things. So if anyone's interested in that, it's really complicated to like share those files because they're like, a working project, they're just sort of like strewn everywhere. But I'm happy to sort of walk people through that process. I will probably record a video actually this week. I've sort of been meaning to do of like a behind the scenes sort of demo for that video. So I'll definitely talk about it, and I'm going to I can share the code. It's like kind of messy. It's like, because when you deal with 2 million files, you have to like separate out everything else into their own folders. I can show you what my folder looks like. It's very, very chaotic. Yeah, of course. Yeah, if you need to take off, like, please feel free. I'm just going to like riff and show some shit now. Yeah, and then definitely like if you want to talk about it during co-working, I'm happy to do that as well. I'll also just like I said, I'll record a video. But so I have a folder that's called Dance Videos. I believe this is probably, let's see how big this is. This is probably only 4 gigabytes of data. That's not as large as I expected it to be. I expect this to be on the size of terabytes. Surprising enough. Inside of here are my output files. So I have a bunch of. These are all of the videos I used as guides. So what I did is I read these in to get all of my key points. So these are what I call my guide files. So these are single clip videos of someone dancing. And then what I did is I wrote a script to, let's see in here. And then here are all of my key point files combined. So there are 117 videos or 110 videos that I ran these across, which equals about 2 million videos or 2 million images, because some of these videos are like an hour or too long. Like if you take Soul Train videos, which are very good because there's like hours and hours of Soul Train video on YouTube, you will get like millions of files. So then I have a little compare script here. Let me open this up and we can see if it works. So what this will do is it will compare my guide video to my all of my 2 million key points or my 2 million images, and it will loop through them. This takes pretty much hours because it's literally comparing every frame to every frame, and it looks for the closest distance. This is, for anyone that's interested, this uses a square distance function to penalize stuff that's too far out. It helps sort of keep things more around each other. I'll definitely walk through this in a video if anyone's interested, but just to quickly show you. And then the last thing it has to do is once I've got the name of that file, I actually need to pull that file. And to do that, there is this really stupidly insane thing that looks up paths. So this is the path to every one of my folders of video. So it looks up the name and then finds the right path and then moves that file down. If I were doing this for a client or if I had all the time in the world, this would be a lot cleaner. As such, I was on a deadline and I just sort of like quickly threw it together, which is why I can't like share everything and just be like, you can use this because it is kind of all over the place. Yeah, so this just uses a bunch of little scripts to like basically recombine video together. And what you end up getting when you bring it into After Effects and then run individual frames is you get that sort of frame by frame animation. And then again, I ran some different techniques in After Effects to either do some masking or to change out timing so that you see a little bit of the source video and then see a little bit of animation, then some source video, like different things like that, to create sort of different rhythms of things. Yeah, so that's essentially the process. So all I did was like the demo I showed you, that plus days and days of time, you could do it yourself with these scripts, I think, of course, yeah. But yeah, that's all that really is, quote unquote, behind the scenes. A couple other little things, like Naoko mentioned, there's like a next stream prediction thing when the audio filters out and stuff, but beyond that, it's like, this is it, and it's just a lot of work because there's so many data points. Any questions?
Derek, for the demo you did tonight, do you have the P5 code available to us?
Yeah, if you open this URL, what I'll do is I'll download it and I'll save it as a zip file and put it in our drive as well. So if you don't want to use the p5.js web editor, but you know how to use p5 elsewhere, I'll just download this code for everyone. I should say, if you're interested in P5, Dan Schiffman is the person to watch. He has millions upon millions of P5 videos on YouTube under his site Coding Train. I'll make a note to add a link for Coding Train as well. So if you are interested in P5, one, I'm happy to help you, but two, you will also learn quite a lot just by watching his videos.
What's the advantage on using P5 instead of processing?
Mostly that runs in the browser. P5 is probably faster. So if you know how to, processing is probably faster. So if you know how to run processing locally, like on your own machine, it's probably better to do it that way. I believe most of these commands will convert almost one-to-one. There might be a couple little things that don't convert, but I assume there's like a load JSON function inside of processing that will just like work the same way. And you'll just have to point this to the right path. I'll look that up just to make sure, but I'm fairly certain. It feels like most people have moved to P5, probably just because it does run in a web browser really easily, and then you can stick it on a website and it works. I feel like processing is kind of slowly dying away, also because it's Java and it's slow. But if you also if you know how to I assume Touch Designer has like a JSON importer. I assume JSON's such a common format these days. There's probably, I assume almost every tool has a way to import JSON and read those coordinates. So you might need to do some funkiness to like take that 75-point array to fix it to XYs, but it could probably work in any tool. So if there is a tool that you like to work in and you don't know how to do it, I'm happy to Google it and try and figure it out with you. All right, so next week, I think we might pick up just a little bit more of this. So I'll cover a little bit more of maybe drawing the skeleton and how you might do that. I would also say in that Goal 11 link, there's a link to a bunch of videos from a company called Universal Everything that are really fun. And they're just like someone walking and they turn them into various types of monsters. So you might want to check that out and just sort of I think it's interesting. There might be some interesting ways to think about maybe doing a similar idea. I think Zach Lieberman is also a really great person. Zach does a bunch of stuff with sort of pose detection and animating that. So between those two sources, I would definitely take a look and maybe you can get some inspiration to draw some fun things. And maybe if I have enough time this week, I'll figure out how to do something more Steve Beck-like more really getting maybe some of that grain or other things in there. And I think we'll also look at using a tool called Detectron. What Detectron will give us is actually silhouettes, pixel by pixel silhouettes, actually masking things. And I think you can also mask body parts out. So my plan is to do something maybe more elsewhere where we can actually cut out people's bodies and then recombine all the shapes in fun, funky ways. That's my plan for next week, so we'll see if that works. Yeah, so that's sort of going to be it for the body detection stuff. If there are videos you saw that we looked at this week and you're like, oh, I wonder if there's some computational way to do that, I'm happy to talk about it. But yeah, for the most part, I think it's like these are the fun things, and then you know, happy to discuss other ways or other techniques to manipulate some of this stuff if anyone's interested. Oh, one other note before I forget, I will be away from my computer during our co-working session on Sunday. So what I'll probably do is in Slack, I'll just say like if you want to show up like earlier in the morning or afterward, I'm gonna be at a soccer game, so I'm like gonna be gone for a couple hours. So if people still want to meet for co-working session, I'll just suggest some times, and like if people want to show up for those times, we can. And then otherwise, I'll be around Tuesday, so we can definitely do stuff on Tuesday. So what I would say is, start to think about like what you maybe want to do with something like this, and then maybe come up with some ideas, and we can talk about them either on Slack or in a co-working session. Sound good? Cool. All right. I apologize for running a little long. Appreciate everyone's patience. And I hope to see you on Slack or in a co-working session this week. And if not, we'll just pick up where we left off next week. All right. Bye, everybody.
Bye.
Thank you.
Thank you.
Yeah.
Thank you.
Bye-bye.
And when is this discussion being posted on YouTube?
Probably tonight. I'll have them up like very soon.
Okay, perfect. Thank you.
Yeah, no worries.